Hello there, welcome back to the Technology Innovation Hub. So let's continue our non-multitenancy Oracle architecture journey. Let me share the screen. We have done 11 sessions up to now. You remember the last session that we were doing was this. We discussed about the multi-process and multi-threaded Oracle database systems, and we got the theoretical aspect. We got to know what is parent process and what is child process and how those things are spawned and process IDs and all. And we got to know very basic about the threaded execution parameter as well. But mostly in that session, we discussed the theoretical aspect. So we did very little bit of practicals. And in this session, let's get into the hands-on and let's dig into more details with regards to this PIDs, PPIDs, threads, and also about this threaded execution parameter. So let's continue. Let me switch to the practical document. So this document I will be uploading. So let's continue from this place. Yeah, I have some SQL. So let me exit from there and let's keep it on Oracle OS login. Fine. So the very first thing, by this time we have explained this one. I think the two paragraphs and this practical I almost did in the previous session as well. But anyway, what is this? A process is a computer program under execution. Linux is running many processes at a given time. All understood. We can monitor them on the terminal using PS command. So process command, we can get the listing of processes using the PS command, or if there's a graphical interface as well, but we are going to stick to the command line. A thread is a lightweight process. We know we discussed this one. Thread D is going to be a part of the process. So a process may contain one or more threads. So that depends on how those scheduling are taking place. And a thread is a lightweight process. Yeah, we can say it's another lightweight process. A process can do more than one unit of work concurrently by creating one or more threads. Very clear. Those threads being lightweight can spawn quickly. Understood. So that is, then it's very clear. Thread is something running within the process, and definitely thread is attached to a process. Okay. Right, in Windows, we know multi-threaded system is there, but we are focusing on Linux here. And last day we mentioned Oracle is a multi-user, multi-processing, multi-threading database. So let's continue. And if you just want to understand what is given in theory above, we can just simply run this command. I think last day also we did this one, but let's continue that one. ps-e grep command. So just to take a look at the processes, you can see here the initial process. I mean the process 0 within the system daemon or the init process. So now it is known as the system daemon, the old OS it is known as the init process. So that is the parent for everything. So last day we mentioned all the process can be traced back to this init process, which has the parent process ID 0. So from there we have the PID 1. So which is going to continue spawning rest of the OS processes as required. And we have the other important process with system D. There's another one, kernel thread process, which is also having the PPID process, parent process ID of 0. So likewise, and this one is a process ID is unique that we learned last day. PID is unique because one parent ID may have n number of PIDs. So therefore, PPID can be duplicated. So, but the PID, process ID, is always unique. Now, for example, now parent ID for this PID is 0, and for this PID 2 also 0. Likewise, this is in a different parent ID, and that is this. So this PID has become the parent for this process. So that is always prior to becoming a parent ID, it has been a process ID. So that is normal. We understood the hierarchy and how this inheritance happens on last day in the PPT. We explained that. So that is very simple, and it is given here: PID, process ID, PPID, parent process ID, C is an integer value of the processor utilization percentage based on values scheduling will be managed. Yeah, that is this one actually, what is mentioned. You saw that there's something called C, right? So that is in most of the cases the values are 0. 0 means the processor utilization is low, but it has we can explain in more detail about the column C, but not necessary at the moment. So actually scheduler will be utilizing this value. Based on that, it will be scheduling either the processor, or because there are situations where heavy processor usages, but there are situations where heavy IO usages. So depending on the requirement, can be IO intensive or it can be CPU intensive. So based on that, the priority should be changed, because if processor is very highly in use, that means it's the peak moment, idle percentage is very low, then the scheduler might not schedule another task for the processor. Whereas scheduler may be trying to schedule another task on IO devices, because the processor is very heavily in use. So likewise, anyway, so let's not get into that discussion now, but just to give an idea about column C, that will give you the processor usage. 0 means a very low value. When it's going high, that means the processor usage is becoming high. So likewise. And then PPID 0 means the initial process or the system daemon process. That's what I just mentioned. When a process start is given unique number called PID. Understood. Whenever process starts, unique ID is assigned for that. That identifies the process in the system. Clear. PIDs are not always assigned in numerical order. Yeah, that is another thing. There is no need to have a particular order. Now, for example, 1, 2, there 3 is not there, but 4. So if you continue to look at this, now here I have restricted this one to 4. No? So let's we can say in 10. And now you can see it is going that PID 1, 2, 5, those things are missing. So like there is no particular order. So that is depends the operating system is assigns a number randomly. Okay, so the PIDs are not always only. Yeah, one very important process is called the init or system D. It is the grandfather of all processes. This was mentioned even in the presentation. This was there. Grandfather of all processes on the system, because all the processes run under it. So that is 0 process. This one, this 0, the daemon process, system D process. Every process can be traced back to init or system D, and it always has the PID of 1. The kernel itself has the PID of 0. Yeah, so if you notice here, the system D will have the PID of 1. PID is 1, and parent process ID is 0. That is what it is given there. So likewise, and you can see here, and it will always have the PID of 1, and the PPID is going to be 0, and the kernel itself has a PID of 0, but you can see here it's going to be what we can see here the PPID. So we better not say PID, we can say PPID. That's much, it will better explain in that way, because it's always the parent. For every process, it is the parent. Fine. So root to, yeah, I think this is the same thing, that is kernel thread, K thread, kernel thread. So that is here, this is what this thread, which has the PPID of 0, this one. Fine, so but we understand in the process IDs and PPIDs. So let's continue. What is a PPID? Parent process ID, or also mentioned. In addition to a unique process ID, each process is assigned to a parent process ID that tells which process started it. The process parent process ID is the PID of the processor's parent. So that's what I mentioned. I mean, you cannot have a PPID without being a PID. So previously it can be a PID, but once it is for another process, it becomes a parent ID. So that's a PPID. And so this command head date, I think we ran that one. You can see that I explained that one. And if you want to relate to Oracle, yes, so we can run this command. So in terms of Oracle, if you look at it, ES minus EF graph Oracle, yeah, number of, you notice here, and parent process ID, is 1 PID. So these are processes, PIDs, Oracle. And I have given here now, you can see the column headers are missing, right? So whenever you say PS minus EF grade, the column headers are disappearing. So these headers are missing, right? So here they are, if you want to get those things, so let's clear the screen. If you want to get those things, you can run this command. I think I have given this PS minus grep E grep and with this PID. So that will give you the headers, which is will give you a much clear picture. So this is about Oracle processes. So in my environment, I have a database up and running. The database is TNS. So we can again very simply we can get that PS minus EF grep theme on process monitor. So this will tell me, yeah, what is running is this one, theme on TNS 19 DB. So that's the database name. And even if you echo that one, echo $, Oracle under SID. So that is the SID, and that is the database up and running on the behind. So these are the background processes. Certain background I have restricted. I want only first 8 rows. So that's why we will see more details. So only 8 background processes are given. So what you have to understand here is PPID 1. So that means what? The Oracle process is running right under the init or the systemd process. That's what it means. Because his parent process is 1 means what? So if you notice previously again, this one, if you get this one, not Oracle, head and this one. So PID 1 is what? Systemd process. Fine. So what has happened here? All Oracle processes are having the parent of 1. That means right under systemd, Oracle processes are running. So for Oracle, the parent ID is system daemon. That is what it means. Then it has the process IDs PO2, PO1, PO2, PO3, all unique process IDs are given here. So that is understood. And we have the set of process IDs, and the parent is the system daemon process. So that is what. Okay. And let's continue the explanation to get the headers. We can do that. And if you look at the Oracle process PPID 1, it is the PP. Yeah. So what it says, look at above Oracle process. PPID is 1, and it's PPID. Yeah. Yeah, that is. I hope you can understand what is mentioned here. Oracle's parent ID is 1. That this one's parent ID is 0. 0 means that is the kernel. That is what it says. You can see this one's parent ID is 0. So 0 is system daemon process. That's all. So that is how the hierarchy goes. We learned that one in the presentation as well. This one I explained that, you may remember. So the hierarchy goes like so 0, this is the original, and we can go down. So that's what has happened actually. So Oracle is running here, and we have parent ID here and its parent also here. So the original parent is the kernel thread. After that, the system daemon and Oracle. That is what it means here. Let's continue. And step 3. So the next step is threads. Now we got to know process IDs. We know now parent process IDs. Now up next is thread. As mentioned above, a thread is a lightweight process or part of a process. Understood. So if you want to get the thread details, we can say PS minus ELF. So L will allow you to count the number of processes. L. So that's what PID is a unique process identifier, LWP unique thread identifier inside the process. So that is it is explained in these columns. You can see NWLP means number of threads. So if you run this command, earlier we ran EF, no. Now we are putting L in between, capital L, no? Remember capital L. So PS minus E capital LF, and I'm extracting E grep. I want to see the Oracle, and I want to see the 50 processes. Actually, not only the process, I want to see the threads as well. So if you look at this output, let's run this. I'm going to run this one. Let's clear the screen. can message it. So this is the output of that. You can see LWP number of threads. So this is the thread ID. This is the process ID, parent process ID, thread ID, and number of threads from this particular ID. Now, for example, you can see all are having number of threads, how many? 1, 1, 1, 1. Except when it's come to here, you have 2 threads. See, what is that process? Or a GEN, ORA GEN means general task process, and there's another one, OFS means the Oracle PI system. So here we have Oracle PI system is having 2 threads are running, and here also we are having 2 threads are running for general tasks. Other than that, we just closely watch, all threads are running as single threads. So within the process, we are having all single threads are running on behalf of the Oracle. These all are background process. Most of them are background process. Yes. Now, that is the normal behavior. That is the normal behavior for Oracle database. You can see the threads, thread count. This is the thread count, and this is the thread number. And normally, now you can see process ID equal thread number, because there is only one process is running, one thread is running. So therefore, always it is equal. But when it's come to here, since we have 2 threads, then the number becomes changed. You can see here 4257, 4258. So other than that, it's similar, 4253, 4253, 4251, 4251. Like, because there's only one thread means one process is running. But here, since you have 2 threads, so therefore there's a number for that. You can see the process ID is not changing. 4257, 4257, same process ID, the second thread within the same process ID. So that is how it's stored. Okay, so here also same process ID is 4262. We have thread ID 4262, same process ID, the second thread is up and down 4266. So that is how it goes. That's the default behavior in Oracle database at OS level. If you continue further, now we can take a look at this. So that is what is explained here. The document, everything is explained. So what I just explained. And n will sort, yeah, that you can go to document. That is to because I have included n here minus n. We can get the head without n as well. So n will sort it based on the access time. That is what is given. And ORA general task, OFST, what is that I have given? You can see Oracle file server background process. Yes, that's what new in 12.2. Yeah, this is new in 12.2. 11G has this. OFS makes the setup and management of the database backup file system much simpler, as without root access, without admin access. This will allow to work with the file system. So that is one of the key features, as well as simplifying the management of PIDs to mount the file system on the database. I have given some example. So PIDs is a file system in usage space. It's a software interface for Unix and Linux-like computer operating system that lets non-privileged users which are not having administrative privilege to own the file system and do some partition creation, mount point, and all. So PIDs file system. So these are a little bit of OS-related knowledge, but doesn't mean I have included. So just go to that one as well. The performance of the OFS file server can be influenced by OFS threads. So I have given you some details here. So because if you are using this, if you are trying to use this feature, for example, when you're clustering, you can make use of that particular feature for mounting and all with NFS and all. So you can utilize this one. But why this is going for this multiple threads? Because of this parameter. This parameter by default allows, you can see, but the default value, it allows up to 4, but it can go up to 128. So since the default value is allowing up to 4, means it can go up to 4 threads. So that's why it is, you can see 2 threads are there. 2 threads. So it can, by default, it can go to 4. We can take a look at OFS threads parameter. So we need to log into Oracle. So let's. We just type show parameter. Yeah, this is the default value, OFS threads. So which is affecting the file system. Actually, it's not the system. We can't say a system because it's an Oracle file server background process. That's how, not the file system. File server background process in a way is allowed to manage the file system. Oracle file server background process. OFS make the setup and management of the database back file system much simpler using Oracle file server technique. So that we can do a separate study later. But the time being, since it is there as a background, that's why I have given some details. So just take a look at this parameter as well, OFS threads parameter. Fine. I think, yeah. So that's just to give you an overview about the threads, processes, and PIDs. And since this one also goes together, the top command. I have given the top command as well for you to get an idea. Okay, so let's do that one also in this same session because I don't want to take long time in this session as well. The top command. So top command is like this. You know this one, right? But I just want to give you because it goes closer to this process listing. Top command, you can see. If you take a look at it, it says now it has a lot of statistics here. The very first thing is load average. So load average lasts 5 minutes, 10 minutes, and 15 minutes. So that's how it goes. Okay, so anyway, let's explain this one in the next session because it will take time to explain the TOP command, top command as well. So we will continue this one in the next session. So I think you can subscribe the video if you like it. So I will meet you soon in the next session. Have a great time. Bye bye.